yesterday when Mark was like, that's derivative. And I was like,
Now you can go to him and say, I know those.
yeah.
Yeah. Okay. So there are a few technical things we need to talk about. Okay.
I'm normally not this yeah.
Okay, so through this worksheet, this is what you did the whole time. Capital F is the antiderivative of little f on an interval I, not really important, if the derivative of big F is the function little f. Okay, so our antiderivative, if we take the derivative, we get back to the original function. That is what you did for all of those 12 problems on the worksheet. Okay? Specifically, this is what it means. Okay? Okay? So, you maybe have seen this squiggly symbol before, and you knew it was for calculus, but you didn't know what it was for. It actually means antiderivative. Okay, this is called an integral. It also means antiderivative. I'm going to use those two interchangeably. Okay. Inside the integral, it has a function they want you to take the antiderivative of, and then that dx, that differential, is telling you with respect to what variable. So since you see a dx, we're taking the antiderivative with respect to x, which you just kind of assumed this is fine. Now, when we take the antiderivative, we get the antiderivative, capital F. However, I have a question for you. What's the derivative of a constant? 0. So technically, we could add a constant to our antiderivative, and we would still get f as a derivative. Do you agree? So every time we take an antiderivative, we have to account for there could be plus a constant. So technically, all of your answers should have a plus c. You guys giggled when you heard about this plus c.
No,
Yeah.
when you said all your answers are wrong.
I know. Okay, that was fun. Very well. Here's the deal. When I give you your antiderivative quiz on Tuesday, if you forget your plus c's, you are not getting 100% even if your antiderivatives are correct. Now, you wouldn't get a 0. Okay, you're not going to get a 0, but you will be docked points. Because you need to understand that there could be a constant added on, any constant added on to that antiderivative, and we'd still get back to the original function when we take the derivative. Okay. All right. A couple notation things. I need you to understand that if we have the derivative inside of an antiderivative, they kind of cancel each other out when we get back to the original function. So the antiderivative of the derivative is the same function. Right? They're like undoing each other. Or along the same lines, the derivative of an antiderivative, those operations cancel each other out. Okay. Now, I'm not going to be super concerned about these two things right here, but I think it's important to talk about as I'm introducing the concept. Okay? Okay, so we're really going to be focused on 3 rules today. And then we're going to talk about like 2 rules on Monday. That is Monday. Monday we'll focus more on the trig and the like natural log and exponential, all of that goodness. But I want to focus today on the simple rules so we can get kind of the notation under control. Okay, so let me ask you this. What is the derivative of a constant?
0.
0. So, which you'll never see, really. But if you have 0 inside of your antiderivative, you get some constant. Okay, kind of a weird one. You're not going to see it very much. Here are the 2 big ones. And really, you could kind of clump them together. But what's the derivative of a number times x? K. I'm using k because we have like this C thing going on. So if we have the antiderivative of k dx, it's kx, but then we have to count for that plus c. We could have a constant added on to the end of it. Its derivative is 0. So if you have just a constant inside of your integral, its antiderivative is just kx plus. And then this is what you all figured out for me. You guys remember when you figured out the power rule on your own for derivatives? You have also figured out the power rule on your own for antiderivatives. Okay? So, way back for derivatives, if we had x raised to a power, you said, okay, multiply by the power, decrease the power by 1. Okay. So now we have to go backwards from that. If we have the power rule inside of the antiderivative, we have to increase the power by 1 and divide by that power. You can either write it like this, or you can write it as 1 over n plus 1 times x to the n plus 1 plus c. I don't care how you write it, but I need you to understand the process. Which, going through this, you all did a very nice job coming up with that rule. Okay. The biggest thing, and you'll remember back from Unit 2, the biggest thing is sometimes we're going to have to rewrite our functions in order to be able to use that. Okay. So we're going to do a couple quick examples, as in 3, and then you're going to have like 15 minutes to do a Christmas themed worksheet. Worksheet, did you hear that? Worksheet?
I like how everybody.
All right. Example number 1. Okay. It is okay to have more than one term inside of an antiderivative. We're just going to do them separately. So for 2x to the 4th, we still have 2 times x now to the what power? Fifth. Divide by the 5. Plus, I don't know why I have that big. X to the 3rd becomes x to the 4th, and we divide by 4, or multiply by 1/4. I really don't care. This is not a correct answer because we are missing plus C. There will be one person in here that will forget the plus C's.
I think that'll
Your goal is to not be that person.
I was gone.
But you're here now.
Give me a break on a test if I don't. I was.
Okay, next one. Can we right this minute apply our power rule to this antiderivative? No. We should probably rewrite it. And you did some practicing back in Unit 2 about rewriting. Okay? We should rewrite this as x to the...
Negative 2/3.
Yep. So now when we take the antiderivative, and I apologize for my squeakiness here, if we increase the power by 1, our power would be 1/3. And so then when we divide by 1/3, it's like multiplying by 3. Isn't this great?
Yeah.
I love it. I love it. And last but not least. What?
It's not bad.
Okay, what are we gonna have to do with this one?
Product rule.
Okay, well,
No.
there's no product rule for antiderivative. Okay,
You could.
there's not one.
You could do.
This is x squared, right? And this is x to the,
Negative 1/3. So you could
sorry,
Positive.
positive 1/3.
1/3.
Yep. Just get back on routine. So we could combine those to be x to the 7/3. Because 2 plus 1/3 is 7/3, right? We would add the exponents together. So now, our antiderivative, we increase our power by 1 and then divide, or in this case, multiply by the reciprocal. Plus C, thank you. Okay. This is great. Sorry, I'm trying to think here. Yeah, we're good.